Hello everyone, Unit 4, Day 4. I'm going to kind of run through the lesson here. I'm going to be covering this in class, but if you're watching this, you either needed further reference, or maybe for whatever reason you're being quarantined, or maybe we're all quarantined. Who knows? Okay? So anyway, I'm talking about translation. So translation is our last example of rigid motion. What do we mean by rigid motion? I mean that these transformations, these rotations, reflections, and translations, okay, these last three, right, preserve size and shape, which means that when we reflect or we rotate or translate a particular shape or a line segment, okay, we preserve the size and shape. It doesn't change, the size and shape of that image, okay? The only one that does is dilation, right? And dilation either forces the image to get larger or get smaller, okay? So anyway, translations. So in the diagram below, right, AB is drawn with these particular endpoints. So it says, draw the image of AB after a translation of 5 units left and 3 units up. Label the image A prime, B prime, and give the coordinates below, okay? So we're going 5 units left and 3 units up. Okay, so we're going to go look at each of these points, and we're going to do exactly that. So I'm going to go -2. I'm going to go 5 units left, which I'm going this way, right? So I'm subtracting 5. Okay, in order to go left, I'm subtracting on the x-axis, and then to go up, right, and to go in this direction, okay, I'm going to go up 3 units. So we do the same for both. So 7 minus 5 and 4 plus 3. So here we get a -7, comma, -5. And here we get a 2, comma, 7. So let's draw those points in here. -7, comma, -5. 2, comma, 7. Here is A prime, B prime. There's our line segment. Okay? So, that being said, okay, what can we say about those? Well, it says calculate the length of AB and A prime and B prime using the distance formula. Show your work below. Okay? I'm not going to take the time to do that, all right? But knowing that this is a rigid motion, all right, well, I'm going to find one of them, I guess. Okay, let's just do it, just to practice the distance formula. All right, so I'm going to do it for the A prime, or AB. All right, so I'm going to go x1, y1, x2, y2. So I'm going to go x2 minus x1 squared plus y2 minus y1 squared. So there's your distance formula. You would get 7 minus -2 squared plus 4 minus -8 squared. Here I'm going to get a 9 squared, and over here I'm going to get a 12 squared, which gives me 81 plus 144, which is equal to the square root of 225, which is equal to 15. Okay, so the length of AB is 15. Now, because this is a rigid motion, and because I don't want to waste a whole lot of time on the video here, if the length of AB is 15, then the length of A prime, B prime must also be 15. Okay, because these are rigid motions, okay, and we do not change size or shape. Okay? So we're just shifting. We're just taking this image and we literally just shifted it. How much? Well, let's see. We went to the left 5. Left 5. 1, 2, 3, 4, 5. Up 3. There's that guy. Left 5. 1, 2, 3, 4, 5. Up 3. Boom. Okay? And so we just took those points and we just shifted it based off of whatever they told us to shift. Okay? So translation is just a shift. All right. Now, the last part, which will kind of tie into your unit quest there, says calculate the slope of AB and A prime, B prime, show your work. What does the result of your calculation tell you about A, B, and A prime, B prime? Okay? And so just looking at the image though, okay, and just knowing my knowledge of translations, okay, I suspect those two things are parallel. Okay, but we can't be sure, and so I'm going to find the slope for both. So I'm going to do AB first. So I'm going to go y2, which is 4, minus y1, negative 8, over x2, which is 7, minus x1, which is a negative 2. And so I end up getting 12 over 9. All right, let's take a look at this guy over here. Slope of A prime, B prime. Well, I'm going to go 7 minus a negative 5 over 2 minus a negative 7. And again, I'm getting 12 over 9, which is equal to 4 over 3. Okay, and so what can we say about both of our slopes? They are the same, which lets us know that AB is parallel to A prime, B prime. Okay? So AB is parallel to A prime, B prime. And that works for all translations of line segments, right? So if you have a line segment and you just translate it, okay, just know that whatever line you just translated, okay, those two line segments are going to be parallel with one another. Even if I moved it over, let's say I moved it over to the left 100 units and down 100 units, okay? These two lines would still be parallel, okay? So just keep that in mind when you're translating line segments, all right? It preserves not only size and shape, but it also preserves the fact that those line segments will be parallel, okay? So anyway, like all rigid motions, translations preserve size and shape of an object. They also map line segments to other line segments that are parallel to the origin. Now we can combine all three rigid motions, okay? So what are they saying there? Well, what that means is that when we're talking about transformations, okay, we typically don't just do one transformation, right? There's usually a couple involved, okay? So example 2, or exercise 2, would be an example of that, right? Where we're undergoing 2 transformations, okay? And so that is why I saved this lesson for last, because it kind of ties in all 3 of these concepts, okay? So in exercise 2, in the diagram shown, kite ABC has undergone 2 transformations, right? So our first transformation mapped this guy to this guy, and then after that translation, we got mapped down to this guy. Okay, so the question is asking which sequence of transformations maps A, B, C, D onto A prime, B prime, C prime, D prime, and then onto A double prime, B double prime, C double prime, D double prime. Okay, so first, let's talk about how do we get from here to here. Well, the name of the chapter is translations, so let me tell you folks, that's a translation right there. Notice that A, B, C, and D are in the same spot, right? A is north, C is south, D is east, B is west, all right? So all we did was we just took this image of this triangle, or I'm sorry, kite, and we shifted it up to that spot, okay? So automatically, we can get rid of 2 of those answers, okay? So sometimes when you're answering multiple choice, the easiest way to answer that is answer the ones that can't be true, okay? So now we have to come up with, all right, okay, question is now, all right, is it 2 or is it 3? Okay, so 2 talks about a translation followed by a rotation. Okay, so here's our image, all right, and so let's say we did rotate it. All right, so now we're here, right? Remember, we're at this guy right here, and so we're trying to figure out how we got from here to here. All right, so let's rotate this guy. All right, so let's say I rotated it, and I guess we're going to have to rotate it clockwise, right? All right, so there's that guy. Okay, so that's after one rotation. So it looks like our kite is like this, right? Never mind the image. Okay, so this is A prime, B prime, C prime, and D prime. Okay? And now, if we were to rotate this guy one more time down to the actual spot where it's at, right? As you can see, this picture, all right, does not line up with this guy here. Okay? So therefore, it can't be a rotation. It has to be the last one, which is a reflection. All right? Take this guy here and delete him, get it out of the way. So it has to be a reflection. All right? And let's just check to be sure. Whoops. All right, and it's actually a reflection over this line right here. Y is equal to x, right? So what happens to our points when reflection over this line? Okay, what happens? Well, our x and y's, they get flipped to y times x. Okay, so a reflection over that means their x and y values get switched. So if this is -2, 1, now point C looks like it's at 1, -2. Okay? So anyway, any further questions on that? Be sure to ask that in class. Okay? But anyway, let's take a look at exercise 3. Okay? So recall, two figures are congruent if a sequence of rigid motions can be used to map one figure onto another. Okay? So we haven't really talked about this, but we're going to start doing proofs, right? And one of our proofs, well, so far we've done, using tools of coordinate geometry to prove certain things, right? Prove that these distances are the same, distance formula. Prove that we have a 90-degree angle, right? Looking for perpendicular. Another method of proving something is congruent, right? And proving two shapes are congruent is to map one image onto the other, right? And what I mean by map of that? I mean that somehow I can get this shape here to line up with this shape here. Okay, so how do we go about doing that? All right, so we got a couple options here. Okay, first option, all right, is I'm going to reflect this guy. Okay, I'm going to reflect him up. All right, more importantly, I want to reflect it so that it looks almost like this on the other side. So let's see what I'm talking about. So I'm going to do a reflection. Reflection where? Well, if you look, we got 1, 2, 3, 4 spaces in between these two images. So I'm going to reflect this image over this line right here. Y is equal to a +1. So reflection over line 1, or y equals 1. Okay, and so let's just see what that looks like. All right, so two values here. This is going to go 2 up here. This is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. 1, 2, 1, 2. 1, 2, 3, 4, 5. 1, 2, 3, 4, and 5. Okay. So there's our first, our new image, right? A prime, B prime, C prime, D prime. Now, how do I get this image from here to map onto here? Well, I'm going to use a translation. Okay, so I'm going to shift right how many spaces? Well, I want to get this point mapped onto this guy, right? So I'm going to have to go over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm going to shift right 10 units. And by doing so, that will get mapped there, that will get mapped there, that will get mapped there, that will get mapped there. And now, okay, our image lands directly on top of that one. Okay, so that's our first sequence. Okay, second one, all right, well, we can do the same thing, all right, instead of, well, actually, let's not. Okay, so I'm going to reflect it. I'm going to reflect this guy. Let's see. So I have 1, 2, 3 spaces in between then. Okay. So let's see. I'm going to okay, how about this? I'm going to translation. So I'm going to go up 1, 2, 3, 4, 5, 6, 7. Translation up 7. And to the left 1 unit. Okay, so each of these points I'm going to go up 7. 1, 2, 3, 4, 5, 6, 7. To the left 1. 1, 2, 3, 4, 5, 6, 7. 1. Okay. There is our new parallelogram. And finally, how do I map this guy onto the other one? I'm going to say a reflection about the y-axis. Okay, so let's see. I'm 2 spaces here, so that's going to be 2 spaces here, right? I am 8 spaces here, so I'm going to go 1, 2, 3, 4, 5, 6, 7, 8. Okay, and you would notice what happened is all those points would line up, and therefore we have mapped that image onto the other one. Okay, so the purpose of this exercise is that there's no wrong way to eat a Reese's here, right? I came up with 2 different transformations, right, but got the same. But map the same image onto the other one, okay? So just know that another way of proving something is using rigid motions to get one shape on top of the other, okay? And so if you noticed, all those points would line up with E, F, G, and H. Therefore, these 2 guys are congruent. Okay, next one. In the diagram shown, okay, EFG can be mapped onto triangle MNP by a sequence of transformations. If the first one is a rotation 90 degrees about the origin, what must be the second transformation? Describe it in as much detail as possible. Okay, you got it there, Mr. Detail. Okay, so here's our image. Copy, paste. Okay, and so what are we doing here? We are rotating it clockwise 90 degrees. So here's our image, and rotate it clockwise. Okay, so I'm just going to copy what that image looks like over here. So F looks like it's right here. E looks like it's right here. And G is way over there. Okay, so there is our rotation of that triangle. And now I'm trying to map this triangle onto this guy right here. So it looks like I could use a reflection. But reflection over what line though? Okay, so let me get rid of this guy here. Okay, so I'm going to count the spaces. 1, 2, 3, 4, 5. There's 6 spaces in between both of those triangles, which means the halfway point would be 3 units. So here is our reflection line. And the equation of that line is y is equal to -2. So describe it in as much detail. Okay, a reflection about the line y equals -2 will map, okay, map what? E to M, okay, it's going to map F to N, and we'll map G to P. And so therefore, triangle EFG and triangle MNP are congruent. Number 5, and call it a DAY. So which sequence of transformations could be used to map ABC onto WXY? Okay, so let me take another image here. Whoops. Stop it. Okay. So we are trying to get, I'm not even going to look at those options. I'm going to try to get this triangle, all right, what are we mapping? ABC onto the other guy. So I'm trying to get this triangle here to map onto this guy. Okay? So how can we do that? Well, I'm going to start with a rotation, because it looks like, all right, we need to get these things to line up here. So I'm going to rotate it this way. I'm going to rotate it counterclockwise 90 degrees. So let's see what kind of image that gives us. All right. It looks like we would have A there, B there, C, looks like it's going to be right here, right? Okay, so we're getting closer. All right. Well, let's see what our options are. Oops. What's it say? A clockwise rotation 90 degrees about the origin, followed by a reflection over the y-axis. So I did this one, right? I started with this one, a counterclockwise by 90, followed by a reflection over that line. So let's see if that gets us where we want to go. Whoops. All right, so a reflection over what line? Y equals 1. That's not going to get us what we want, right? Reflection over that line is going to bring that triangle down here. Right? So that doesn't look like the image. Okay? So we can cross that one out. Let's see, a reflection over the line y equals -x, followed by a translation of 2 units to the right and 3 units up. Okay. Well, let's talk about that one. So a reflection over the line y equals x. So I'm going to delete this guy. Okay, so reflection over the line y equals, or I'm sorry, -x. So it's going to be this guy right here. Okay, that's the equation, y equals -x. So let's reflect it over that. Okay, so this is going to be 1, 2, 3, 1, 2, right, 3 units there. That one's B. That one's A. Looks like C. Whoops. I think it's going to be somewhere right here, right? Okay, very good. So there's that triangle, a reflection over that line. And then let's see, followed by a translation of 2 units to the right and 3 units up. This one's looking pretty promising. All right, so there's our reflection, and I'm going to go 2 units to the right, so 1, 2, 3 units up brings me there, 2 units to the right brings me there, 2 units to the right. Aha! That's our winner. Winner, winner, chicken dinner. Okay? So I'll be going through this in class. So if you're watching this, you're either, well, we're either been quarantined or maybe you just need a better reference, okay? But anyway, we will work on these in class. This is probably the most difficult one we're going to see throughout this unit because this ties in all three concepts, right? So anyway, good luck, you guys, and